Trigonometric identities. Simplify trigonometric expressions. So this is another expression which we'll try to simplify here. Tan cube x divided by 1 plus tan square x. Well, I'll show you two different ways of doing it. One using Pythagorean identities and the other converting tan into sine and cos. Okay, so let's do first by converting tan into sine and cos. So we have tan cube x. So tan cube can be written as sine cube x over cos cube x, correct? Divided by 1 plus tan square x. 1 plus tan square x can be written as sine square x plus cos square x. So first step is to write tan as ratio of sine and cos, right? Now, so that is a quotient identity if you remember. Now this is equal to, so what we will do now is we'll write this as sine cube x over cos cube x times. Now what I do is, you know, there are 4 layers of fractions here. So let's kind of simplify it, right? So we'll do common denominator, and the common denominator will give me cos square x plus sine square x here, and denominator will be cos square x. It is this term divided by that term, right? So what we can write this as, okay, let me first write as divide by 1 plus sine square x over cos square x. So I'm writing this as, so I'm taking cos square x common, right? And so I get cos square x plus sine square x. I showed you this step in between just to give you an idea that I'm not using this line as divide by just to make it 2 layers, but I could have jumped on to the next statement straight away. So let's see what next is. So we'll write sine cube x over cos cube x, and that means times reverse reciprocal of it, correct? So we'll do cos square x over, and you know what cos square x plus sine square x is? That is 1, correct? I hope you remember these identities. These are Pythagorean identities, right? So cos square x plus sine square x is 1. So we can write 1 here, right? So divided is converted to multiply, and we get cos square x over 1, correct? Now cos square x and cos cube x, 2 of them get cancelled. Cos square x will get cancelled, and we are left here with sine cube x over cos x. So that is a simplified expression for the given expression, right? Now another alternate way of doing it is that we could use another Pythagorean identity. Now if you don't remember, let me prove those for you now. Again, as a reminder, let's say this is our right angle triangle, right? And I'm calling this as the opposite side, and that my angle x. This is adjacent, and that's hypotenuse, correct? So just draw a line here. Okay, and use a different ink. So, you know, a square plus o square equals to h square, correct? Because this is a right angle triangle, correct? So side arm squares is equal to sum of their squares is equal to the hypotenuse square. So if I divide all these by a square, then what happens? Look at it. So a square, divide this by a square, and divide this by a square. So what happens? A over a is 1, right? So we get 1. 1 square is 1. Plus o over a, opposite over adjacent is tan x, and square of that. So 1 plus tan square x is equal to h over a. H over a secant x, reciprocal of cos x. Do you see that? So you get secant square x. So that's another Pythagorean identity, right? Which we can use. Here we can replace 1 plus tan square x by secant square x, correct? So that's what I'm going to do here. Okay? You remember this is also Pythagorean. In this case, what do? here we divide by, you get a square plus o square equals to h square, and to get cos and sine we divide by the hypotenuse, right? So h square. And when you do that, so a over h is cos, so cos square x plus sine square x equals to 1. That is what we get. So remember these are Pythagorean identities, right, which we are using. Now let's use this identity, and then we can write tan cube x over 1 plus tan square x as equal to, we'll write tan cube x in the numerator, and in the denominator 1 plus tan square x is secant square x. We'll write this as secant square x, correct? Now tan cube x, so let me write this again. As I was saying, is divide by secant square x, that is 1 over cos square x, right? So I can write this as tan cube x, and let me write this as divide by secant square x. That means tan cube x multiplied by 1 over secant square x, right? There was no need to write this statement, but some students find that convenient, and that's why I'm writing. I should have written it straight from here to this, right? And what is secant square x? It's the reciprocal of cos. So we get tan cube x times cos square x. Correct? Now you know what you are going to get. I could have written tan cube x earlier as sine cube x over cos cube x, right? And then cos square x. Now cos square x cancels with cos square x, and you're left with sine cube x over cos x. You see that? So you get the same result both ways, right? So I just ran over a couple of unnecessary steps here. I could have written sine cube x over cos cube x for tan cube x, that, and secant square x is 1 over cos square x, and next statement I would have come to that, right? So could have done it in 3 steps, right? But just included these few for clarity of some of the students. Okay, thank you.